Hi, it's Marcus. I'm a third-year medical student from the University of Cambridge, and I recently graduated from the IB with a total of 43 points. In this video, I'm going to be reading and reacting to my maths IA, which I wrote more than 3 years ago now. This is the IA that helped me get a 7 in maths, because it scored 19 out of 20, and given my year was the year that didn't have exams, my score was solely based on this IA. So having that great score was vital in essentially letting me get into university. The purpose of this video is to really shed some light on what makes a good IA. Now, by no means is this IA exemplary, but it did score 19 out of 20, and it was probably one of the best pieces of writing I did in my time in school. I hope this video spurs you on, gives you ideas, and helps you write the best IA possible. Let's get started. Here we have my IA. This is the title page. It's quite simple. Calculating the surface area of a small intestine through the modeling of an individual villus. I remember lots of people did some sort of linear regression stuff, and other people did some wacky things, sort of like me. I wanted to take more of the scientist roots, associate what I was learning in biology with what I wanted to study in maths. So this is what I landed on. It was a completely random idea. I have no idea how I came up with it. Like, I do feel for you if you're struggling with finding a good research question for your maths IA, because it is so tough to do. So what I would recommend doing is firstly going through the web, looking at old IAs and potentially gaining inspiration from those. Obviously don't copy them, that would be stupid, you can't do that, but inspiration is always good. And then set up a meeting with your maths teacher, because they really should help you figure out what your areas of interests are and what kind of things you could be doing for your IA. I remember my maths teacher was really helpful. I came to her with this idea and she was like, sure, go for it. If you're interested in it, just do it. So yeah, I do feel for you if you're struggling to find a research question, because it is not easy. It is really quite tough. The small intestine, also known as the gut, is a 7-meter long tube which is responsible for the absorption of food molecules into the bloodstream. It has several important structural components which allow it to perform this function to the best of its ability. The whole of this introduction is just me mansplaining biology to mathematicians. Like, this is all very basic stuff. They really should know this. It's just the sort of thing you have to do in an IA. You have to be as clear as possible and really just communicate exactly what you're doing and exactly why you're doing it. I think that's the key with a maths IA. Explain exactly why you're doing everything. And the introduction is the first part of that. You've got to really set the stage for what you're writing about. Villi are tiny finger-like structures which line the interior of the small intestine. Yep, that's cool. I show an image of the small intestine, and then I go on down to here. There are some structures which I cannot include in my exploration. So I talk about microvilli because, I mean, microvilli are like tiny little hairs. I'm not gonna actually calculate the surface area of those because I don't know how it would be possible. So yeah, they're just too small to observe. I don't have the equipment to observe them, so we ignored them. And then the small area, which is the crypt, this little area. So yeah, I chose to ignore that too. As you can see here, I actually chose to ignore things which would have made the investigation a lot more accurate, but it was okay because despite me ignoring it, I firstly had a reason to ignore it, so it made sense, and secondly, I explained it. I told them I was ignoring it, and I explained why I was ignoring it. And I'm doing things right because I'm communicating my ideas. I'm explaining why I'm doing things. This is a funny sentence. This seems like a slightly strange topic to want to explore. So let me explain. Like, this kind of thing, an IA is really such a creative piece of writing if you think about it. You're exploring. It's called a maths exploration. It's not called an IA. So writing sort of informally isn't the worst thing in the world. Like, obviously you're meant to write academically and you can write academically, but this kind of thing is really cool and they do like it. So if you want to score highly on communication, this is the way to go. After my introduction, I had a rationale. So this is to explain, okay, why am I doing this? I've described the topic. Why do I want to do this? So I've been interested in aspects of human anatomy. I wanted to pursue medicine. Hey, I'm now studying medicine. Who would have thought it? Okay, so with this, you see how many I's I am using. It's insane. Like, I use I love this. I want to do this. I really like this. This is something that you really should be doing in your IA because it is a personal piece of writing. So for the rationale, you want to explain why you are interested in the subject. So it has to be personal. It has to be in the first person. Additionally, I love the idea of being able to use primary data. That was actually something quite cool because I actually went to the lab, used a microscope, and looked at the villi and then based my investigation off of that to carry out an investigation independently, relying on secondary data from different sources to a minimal extent. I also love spending time in the lab, and this exploration was a chance for me to use those laboratory skills for a practical application. So yeah, the fact that I was able to use primary data for this is something that is completely out there, because doing a maths IA, if you want to use primary data, you're probably going to have to do some sort of like questionnaire. And doing questionnaires can be really dodgy and time consuming and tough to do. So it was a very large advantage I had that I could use this primary data without really compromising any sort of quality in my IA. So a maths IA can be something more of a random exploration into a subject, into a niche subject of maths. It can also be an exploration into something that's very common around the world. So for example, doing something related to sports. People do things to do with rockets and I don't know, how they fly and their arcs and stuff. You can do that kind of thing. I know a friend who did something to do with time dilation. You just pick something that you're interested in. I think that's the main idea. You pick something you're interested in and you do something mathsy related to it. So this is where the rationale comes in. You need to explain why you're interested. A single paragraph. How am I going to go about this? This is the kind of writing you want to be doing for the IA. Just very descriptive, putting your point across. This is how you score top marks in communication. Okay, this is just my methodology. You need a methodology, you need to explain how you do it. That's okay. I then show them how I do it. I took 11 villi, I measured their lengths, their widths, I had figures. This is important. Make sure you always show what you're doing as well as describing what you're doing. If you show like this, what you're actually doing is really cool. Okay, here is something important. I chose villi from the same section of the small intestine. This is an issue, as different parts of the small intestine have slightly varying sizes of villi. However, I was only able to obtain a small section of small intestine, as it would be unethical and impractical to use such a large organ when such a small part is being used. There was no mathematical reason as to why I chose 11 villi. Okay, I probably should have done more in retrospect, and I probably should have had a reason. If you're gonna have primary data, have a reason behind the primary data and explain it. Me highlighting an issue with my study right from the get-go is something that is really valuable. Because if you just describe what you're doing and some of it doesn't make sense, some of it makes sense, the examiner is gonna be reading it and being like, but why? Why didn't you do this? Why didn't you do that? If you immediately highlight the issues and explain why you did something and why you didn't, then that immediately cancels out the doubt in the examiner's mind and they immediately trust you more. And therefore you score more on reflection, on communication, and on everything. You can still have a discussion section at the end where you evaluate the limitations of your study, but doing it throughout with little things can be really beneficial. Okay, so I found the mean length of the villi, mean width of the villi. This is fancy maths for calculating the mean. Here's an actual image I took, well, two images stuck together. I literally just stuck two images together. And then I drew, I literally, okay, for this, I literally went on like Word and took like a pen or something and just drew around it. Like, it was the least efficient thing I possibly could have done, and it took me ages to figure out how I could draw around it, because I didn't want to be doing experiments and mathematical stuff on this thing because it's ugly. Having an actual line is a lot easier. So yeah. Okay, now that first person, have the size of the villi, I have to start modeling the curve of the function to represent the outline of the individual villas. To obtain the micrograph, I took a micrograph, showed my figure 4, fine. One issue that I came across is that bovine villi are much larger than human villi. I must scale down the size, fine. So here I've got basically two sections. So I start modeling using an ellipse, as the shape of the villus matches the shape of an ellipse. So here's the general equation for an ellipse, that's pretty basic. A and B represent the two focal radii. Along the x-axis and the y-axis respectively, an ellipse consists of a major and a minor axis. These are the diameter of the ellipse at the longest and shortest points. Okay, that makes sense. So it's if you have an ellipse, it's this bit and this bit. That's fine, easy. Diameter is always twice the length of the radius. This means that the minor axis is equal to 2a and the major axis is equal to 2b. Okay, so minor axis is this, therefore 2a equals this, as I explained above. Therefore a squared equals this. And I get this equation for the ellipse. So here I draw my ellipse and I give it a translation. So it sort of shifts to the right. I now do some cool mathsy stuff, vertical translation as well. And I get this final equation for the ellipse. And I can see it here. So obviously there's a section up here And there's a section down here which just don't fit. It's not perfect. So this is where modeling comes in. Like, you can model something and you're trying to fit basically lines together. Because what I did was I just highlighted, okay, it's not perfect. And I know that. So what I'm gonna do, instead of just thinking, oh, it's not perfect, but it's okay, it's enough, and I'll deal with that. You can't do that because that's just not very exploratory. So what I did was like, okay, it's not perfect. Let me find a solution. So a solution could be a fix to this method, or it could be just going out and finding a different method totally. So that's what I did. I literally just went out and was like, okay, this one doesn't work. Let me figure out another method for modeling using a different equation of a line. So I did think initially of like a sine line, but I think a sine line would go like this, and that's just not good. It would not work. Okay, so if you did this modeling in a completely different methods, why did you include this first one? Well, including this first one was really useful because it showed that I tried things, they didn't work, and I understood they didn't work, and then I went and tried something else. It shows that I understood the maths behind it, and that is something that's so valuable. So yeah, both personal engagement, mathematical presentation, reflection, all of this, even use of mathematics, which is 6 points, all of these criteria benefited from me understanding that I did something wrong, but still showing that I did that wrong thing and then trying something new. Having decided that an ellipse would not work, I had to look for other types of equation which would allow me to create an accurate representation of a villus using a graph. Here, I came across using a rational function. I had never heard of these before doing this, and I don't remember what they mean. It's some pretty complicated maths from now on. So the curve that I need has to have several parameters which will allow me to create the right shape. The first two parameters are the two vertical asymptotes at either side of the villus. I've got to have two asymptotes either side of the villus, right? Which is creating the finger-like shape. I then need one vertical asymptote at the maximum of the center curve so that the curve creates a concave shape in the center. Here is the outline of the equation I need. That's pretty cool. I looked this up. Like, this isn't maths that you're meant to know. You're not meant to just know and understand all the maths you use for an IA. Like, you've got to look things up, understand them from looking them up, and from using them in your own IA. So like by the end, I understood this maths inside out. But like obviously now, I don't. To find the equations for the asymptotes to this curve, okay, so what I'm doing is I've got this thing, and I've got to find the asymptotes to the curve, right? Okay. The curve has to cross the x-axis at 0, 0 and 0.350 to fit with the curve of the villus. Good. Therefore, a equals negative 35. Find the values of b and c to find the vertical asymptotes. Input the values of x and y to determine the values of b and c. So the point is this, which is the maximum of center section of the function, 0.175.8. So I use this point up here, input it into the equation to find b and c. So then I rearrange the equation. I literally just input into the equation, rearrange, and I get left with what b is. Therefore, I can get c in terms of b. Basically now, I sort of have like simultaneous equations because I have two variables which I need to find. So in the end, I do find b, which is good. I then find the equations for the asymptotes. So I literally find like these equations and this one. And now I have the final equation of the curve. That's really cool. Okay, the final curve with the shape of the villus superimposed is shown by figure 9. Like, just a sentence being like, this is what I have, just makes it so clear and so much easier to read. Like, I know what's going on in this IA despite not understanding like any of the maths. I haven't done maths for 2 years and I still understand what's going on because it's just clear, and that's what you want to aim for with your maths IA. So here we have figure 9. You can see that it does sort of fit a lot better because like the other one had like this thing here. These are pretty easily cancelled out. They do have little triangles here, but I can get rid of those quite easily. This limitation can easily be overcome by subtracting the area of these triangles from the area underneath curve y. since the ellipse does not fit well, I conclude that the rational function fits better, which will give you less error in my calculations. I understand the other curves, quadratic equation, trigonometric equation, however I was satisfied, and it would be impractical to attempt other types, which probably wouldn't work as well with the space and time limitations that this exploration presents. Remember, this exploration has to be like 20 pages maximum or something like that. I think the other ones was 12, like chemistry and biology, but this one's 18 pages. Like, I then evaluate a little bit. I realized that a lot of the judgment of which curve fits best has been done by eye, and so might not be the most reliable source of judgment. In order to evaluate the effectiveness of a curve, I deliberated over creating a function which would calculate the effectiveness of a curve by selecting a number of points along the function and measuring how far away from the villus outline they are. This would be totaled, and then the numerical results for the two graphs could be compared to make a more informed judgment call. However, I did not have the space to include this, so I settled with making the judgments by eye and attempt to evaluate each curve by eye. So I identify a problem, I suggest a solution, and then I'm like, there's no space for the solution, so we're just gonna leave it be. It's not ideal. Obviously, I would ideally do this, but it's not bad. Like, it makes sense. So I don't think this was a bad call on my part, not at all. So this is my equation. I have my equation based off of the values I found earlier. And what I'm doing is I'm gonna try to find the area underneath the curve, because I'm trying to find the area of the villus, so that then I can find the area of the small intestine, like the whole small intestine that's like in there. So that means I need to integrate, and I'd only ever integrated like regular things. Integrating really isn't that hard, particularly the stuff they give you in exams at standard level at least. So now we start integrating. There is long division, which I was forced to use a calculator for. Obviously, I'm not going to do long division in my head. That would be stupid. Like this stuff, like just me trying things out, figuring out how on earth I could do this. I understand this is not ideal process, which is highly recognizable by my peers. Oh, this is another thing. An IA is meant to be for your peers, technically. So like, you're meant to be able to give the IA to someone at the same level as you, and they're meant to understand what you're doing and follow each step. So this is why every single step I outline in a new paragraph, because it's just easier to follow along. Here, I was forced to use a calculator for the polynomial long division, as extremely small numbers were used. And I understand that having to do this is not ideal, as polynomial long division is a process which is highly recognizable by my peers, and it is useful to be able to see such processes taken out of a theoretical and used in a more practical piece of work. However, it is impractical and unnecessary to do calculations with such small numbers, and so I chose to not include such work in. So basically, I just stuck it into a calculator online and it did it for me. So I've simplified the integrals. I can start to calculate the value of each integral and add them up. So I have one integral here, and I just need to add them up. So I have the first one, 0.35, and I need to solve the remainder. So I've used something called partial fraction decomposition, where, I explain it, where I undergo the process of starting with the simplified answer and taking it back apart, of decomposing the final expression into its initial polynomial fractions. This makes no sense to me. In retrospect, this may have been where I lost the mark in terms of communication, because I have no idea what's going on right now. I do something, and then I factorize it. What the hell is going on? This is so confusing. I am so confused. But there is something to take away from this. It isn't just a web of incoherent maths. There are lines of actual words in between the maths. So like, at each step, I describe exactly what I'm doing in words. This is something that mathematicians suck at doing. Like, when I was doing maths in IB and before, I would just sort of do the maths and not explain and just not explain what I was doing. I would just write, and I would skip steps, and I would just get to the answer, and that was it. Because all I needed in an exam was the answer. But here, the point isn't the answer. The point is the process. So I really needed to use both words and numbers to describe the process. And this is something you can clearly see I did well, because I just merged them so you can actually follow along where I was going. If I didn't have these, and I just had a list of things, it would be even harder to understand. Like it just wouldn't work. Going through this integration has helped me understand the process on how integration can be done on a somewhat irregular graph, where typically I would come to the answer by plotting it into my calculator. Instead, going further with long division in partial fractions has given me a depth to the calculation which I wouldn't otherwise achieve. This is personal engagement. This is me being like, this is cool, I'm exploring, I'm learning, this is interesting to me. But it's also reflection. What did I learn from this? How did I gain skills from this? And these are both things that the IB is really and these are both things that the IB really values, so keep this in mind. However, with this integration, I have only found the area under the curve, not the surface area of one side of the villus. As shown with figure 9, remember that figure with the two triangle spaces? There are two right angles which need to be accounted for. So these I literally just like, these are like the basic shapes that you get on Microsoft Word. Like, that's so stupid. Like, as professional as a piece of mathematical writing this is, as an academic exploration, like, the methods I used for the science bit are terrible. So I get the two areas of the triangle, that's okay. I subtract it and I multiply it by 2. So now I have the surface area of a villus. And then use secondary data, 3,000 villi per centimeter of lumen. So the surface area per centimeter of lumen is this. So the lumen has a diameter of 3 centimeters. So it has a cross-sectional circumference of 9.4 centimeters. Therefore, if I times that by 500, because it's 5 meters, I get this many centimeters squared. So this gives me the total surface area of the small intestine as 6.27 meters squared. 6.27 meters squared. That doesn't seem right. That seems a lot less than it should be. Okay, so now I go on to evaluations and whether what I've done is actually relevant and useful. So the exploration had a lot of flaws and limitations, which did not lend a hand to the accuracy. Literature value is of 250 meters squared. My value was 13.3. No, sorry, my value was 6. This is a percentage error of 4,000%. I had a percentage error of 4,000%, and it was okay. I say that this was to be expected and can be explained. Microvilli, yeah, exactly. Okay, so the microvilli, if I ignore the microvilli, the surface area of the small intestine is going to be so much smaller in my calculations than it really is in real life. Perhaps a more biological methods could be used for a greater degree of accuracy. However, finding the surface area of microvilli is no easy feat. Another limitation is the use of cow small intestine, done for practical reasons and ethical reasons. 2 micrographs were used, something that can easily be overcome by finding a small animal small intestine with smaller villi. That's easy. Finally, the method that was used to model, in my opinion, the best option. Despite the large error, I am still pleased with the outcome of this exploration. All in all, that was really quite different to what I was expecting. Like, I knew I had some error, but I didn't expect 4,000%. And I did expect to be confused by all the maths. Like, the maths was confusing. All of the integrations, I didn't really understand. But don't be scared. If you're doing math standard level, then doing this level of complicated maths probably isn't needed. Like, I did a lot of research in figuring out how to do this kind of thing, to put this in. But for standard level, it's really not needed. Like, people did linear regressions, like, and that's enough. They got 4 or 5 in their mathsy section of the IA. Like, it wasn't terrible. So this kind of level of maths is really only if you're doing higher level. Let me know what you think of my IA. Is it terrible? Is it awesome? Did I not deserve to have a 19? And should I have failed the IB instead? Let me know. I don't care. I hope you found that valuable, and I'll see you in the next one.